tip number 1. So tip number 1 is going to be always keep your filtrate until the end of your assay. Let's say this is the first time you're running the assay, you're just trying different molecular weight cutoff, and the one that you choose actually lets quite a lot of your protein passing through the filtrate. If you discard your filtrate, your protein is gone. If you keep it until the end, you can just refilter it to recover your sample. So always keep your filtrates. And then tip number 2 is going to be on recovery. Here, like Pavel mentioned, this is a very thin and narrow filter cup. You may not have access with a pipette. So what you want to do is to perform a reverse spin. So here, you just take your filter cup and flip it upside down inside your concentrate collection tube. That is your reverse spin. You put it back in your centrifuge for one last spin, and you'll recover every single microliter of your concentrates. Tip 3, and this is in the case you put your sample, you perform your first spin, and then you collected your sample from the filter cup, but you cannot detect your protein in your concentrates. Usually what people may be worried is that maybe the protein bind to the membrane. However, as it was mentioned earlier, regenerated cellulose is very low protein binding, so this is unlikely. However, what may have happened is that the protein was over-concentrated and crashed out of solution. So this really depends on your protein, potentially the buffer as well. So what we recommend is to monitor your concentration of your sample. Here you have graduation to calculate the concentration factor. And when you're running this assay for the first time, really try several timings and several centrifugation speed to avoid this protein precipitation effect. I'll mention tip number 4. You may be able to reload your sample a little bit. So what you will do is you first load your 4 ml, perform a first spin, maybe just 10 minutes to kind of evacuate as much solution as possible. You see there's a bit of room here in the collection tube, especially if you put it in a swing bucket brooder. So you evacuate 2 ml, and then you can reload your sample on the top. So you can process your 6 ml without a problem. As long as your sample is not too concentrated, you want to avoid clogging, and as long as you don't wait for the very last centrifugal spin, because you don't want to allow your membrane to dry. Once it's dry, it won't be efficient to filter your sample. So although it's single use, as long as you reload your sample during the assay, you can work with a 6 ml sample with this kind of device. So we mentioned viruses, nucleic acid, for instance, in the presentation, and this is because those filters can be used for other type of samples than proteins. However, it's important to keep in mind that you will consider different parameters if you're working with nucleic acid or viruses when you're picking your molecular weight cutoff. So here are some examples. So that's tip number 5. If you're working with nucleic acid, you need to consider the rod shape of this molecule, contrary to protein that may be globular, the length of in nucleotides, the strandedness of your nucleic acid, the form if you're working with plasmid, whether it's supercoiled or maybe relaxed, and the velocity of the centrifugation as well. If you're working with viruses, you need to take into account the buffer composition and the velocity of centrifugation. So most of the times when you're working with nucleic acid or viruses, we'll recommend decreasing the centrifugal speeds to have something a bit more gentle for these molecules. So we have a range of application notes for this type of application, so don't hesitate to contact us for some guidelines. So it's tip number 6. If you're working with a very heterogeneous sample, you will have different sizes of protein, for instance, here. And your large protein here in blue may accumulate on top of the filter, and this may form a gel-like layer that will act as a secondary filter on top of your membrane already. And this may block the passage of those yellow molecules that are smaller. These should go through without a problem through the membranes, but because of this gel layer, these are actually blocked, and so you have membrane polarization. To address this potential issue, industrial cell, we have included a magnetic stir bar here. So this magnetic stir bar is going to mix the sample right on top of the membrane without touching it to avoid any accumulation of proteins or molecules.